Good morning. Today we're going to be talking about tangents of circles. A tangent is a line that is in the same plane as the circle, and it intersects the circle at exactly one point. Only this, one point that they're attached to each other. And that's simply called the point of tangency. Also, a common tangent is a line that is a tangent to two separate circles. This is a common tangent here. There's only one point where they touch. A tangent is, since it's touching one point of the circle, the shortest distance from a point to a line is a 90-degree angle. So this, from the center to the tangent, is a right angle. So if two segments from the same point, this point here, are tangent to the same circle, these two segments are congruent. And circumscribed polygons. Circumscribed polygons have a tangent to the circle. So this triangle right here touches the circle in exactly 3 spots. There, there, and there. Same goes for the other shapes. So when we look at this, we want to see how many common tangents does this figure below have. And the answer, those circles should be a little bit closer, but the answer is, of course, 1. That's going to be this point right here. This point right here. So the answer is 1. Okay, KL is a radius of K. So that's this line right here. That's a radius. And they're telling me that ML is a tangent. That means that this angle right here has to be a right angle. If that's true, then these numbers should work out to work with the Pythagorean theorem. So we have to see if 20 squared plus 21 squared, oops, equals 29 squared. So is this true? Well, when I do this side of the equation, I end up with 1282. And over here I get 841. They're not equal. So no, this is not a tangent. In the figure, they're telling us that WE is tangent to circle D at W. So again, we have a right triangle. So now we have to figure out what X is. Well, we know that this leg is 24. So if we're going to do the Pythagorean theorem, I'm going to use 24 for 1. What's the other leg? The other leg is X. And now, oh boy, we've got this third side. The hypotenuse is 16 plus X. So 16 plus X squared. You know what that means? I'm going to have to do some, ooh, I'm gonna have to math pretty hard. Okay, so this is 16 plus x times 16 plus x. My equation's getting longer. Okay, so now I have to distribute. So I've got x squared plus 16x plus 16x plus 256. Now, what am I going to do with this? Okay, I have to combine like terms still. So 24 squared plus x squared equals x squared plus 32x plus 256. I'm going to divide both sides by x squared to get rid of that. And then I've got 24 squared equals 32x plus 256. I'm going to change this 24 squared to 526. I'm going to subtract 256. And that gives me 270 equals 32x. And that gives me x equals 8.4. Whew, that's a long one. Okay, next one. All right, so I have to find x if st is tangent. Again, I have a tangent, so this is going to be a right angle here. So now I have to figure out what I'm going to plug into the Pythagorean theorem. So a squared plus b squared equals c squared. 15 squared plus 36 squared equals, oh, I don't even have anything here. How am I supposed to figure that out? Well, here's the clue. What I'm going to do is I know that this is 15 right here because that's the radius. But I'm going to make a new variable and call it y for the whole thing. Because once I figure out what y is, then I can subtract 15 from it, this 15, and then I'll get x. Okay, so this is going to be easier than you think. So this is y squared. All right, so I end up with 225 plus 1296 equals y squared. 1521 equals y squared. And the square root of the 521 is 39. So now I know that this whole thing is 39. So I can subtract the 15. And I end up with 24. So that's x right there. All right. Let's see if we can figure this one out. Well, I'm looking here and I think I don't see much that's going to help me out. I don't have any right triangles, but I can make one right here. And I know that this is 30 because I rotated the radius from here over to there. So now I can figure this out, right? Pythagorean theorem again. Okay, 30 squared plus 40 squared equals, here we are again. I could use 30 plus x squared, but if you look at this, be careful. This is going to be a 3, 4, 5 triangle scaled by 10, so I'm going to call it 50 squared. Once I figure out, no. Okay, I want to back that up a little bit. I can say that this is 30 plus x squared. And I can do all that math, and I will get the right answer. But what I'm noticing is that this is a 3, 4, 5 triangle scaled by 10. So this whole thing is 50. So then x equals 50 minus 30. So x is 20. If you choose to do this, it's still correct. You still will end up with the same answer of 20. Okay, so now we're looking at packaging this bouncy ball thing. And this triangle is circumscribed about circle G, which is the bouncy ball. Find the perimeter of this triangle. Well, one of the theorems says that if a point is tangent to a circle, then these two segments have to be congruent. So if this is 12, so is this. These two segments have to be the same. This is 6. These two segments have to be the same. Well, if this green portion of this segment is 6, then the rest of it has got to be 10. So then this is 10. Now, in order to figure out the perimeter, I'm just going to take 12 plus 12 plus 10 plus 10 plus 6 plus 6. And I add all that up, and I get 56 centimeters. All right, well, again, here it is. This point is tangent, this segment is tangent to the circle, and this segment is tangent to the circle. Well, that means that these are congruent. That means I set them equal. Okay, so 3x plus 2 equals 4x minus 3. So we do the math, we end up with x equals 5. So now we have another jewelry one. Okay, Juanita is designing a pendant with a circular gem inscribed in a triangle. Find the values of x, y, and z. Then find the perimeter. Okay, got this. All right, so let's find x, just because it's first. I see x is here. Well, those are tangents again, so we're going to set them equal. So 2x plus 2 equals 3x minus 3. All right, we do the math, we get x equals 5. So that's x, but now we have to find the value of that when we plug it back in. So let's say x is 5, we can say 3 times 5 minus 3 equals 12. Okay, so this and this are 12. All right, x, y, let's do y. 5y minus 2 equals 3y plus 2. So we're going to take 2y away, so we end up with 3y away, so we end up with 2y equals 4. So y equals 2. Okay, so let's plug it back in. Y times, that's 3 times 2 plus 2 equals 8. So this is 8. Let's do Z. Okay. Z plus 4 equals 34 minus 2Z. Whoops. All right. So we're going to add 2Z. So I have 3Z equals 30. So Z equals 10. I'm going to plug it back in. This says Z plus 4, so I'm going to make it 14 on this side and 14 over here. So now what we do is we just add them all up to get the perimeter. So we've got 12 plus 12 plus 8 plus 8 plus 14 plus 14. And that all equals up to 68. So we have the perimeter. All right. See you tomorrow. Have a good night.